Hi, thank you everybody. Welcome to our webinar on DevSecOps, what, when, what, why and how even. My name's Alan Panting. I'm an account manager with Not So Secure Global Security. My job effectively is to look after customers within Europe, Middle East and the Asia regions. I'm in a very fortunate role. I'm part of a global team which deliver what we believe is a world-class ethical hacking and training services. Shortly, I'll be handing you over to Jovin Lobo. He's one of our security consultants and also one of our black hat trainers. So very well experienced in the subject of training and obviously pen testing as such. I promised he would do a lot better job of explaining what this is all about. But if you don't mind, before we get started, I just want to tell you a little bit about us. Not So Secure is part of Clarinet Cybersecurity. We're known for two things effectively: we hack and we teach. When I say we hack, pen testing, red teaming is just one of the few things that we do. We also do things, a whole comprehensive range of training courses, all focused around the hacker arena, both defensive and offensive. We also do a lot of other interesting stuff like MDR, continuous security, and some other consultancy skills. So, tell you, just to before we actually get kicked off on this, is just quickly run about. We founded back in '96. We've got 2,500 staff, loads of business clients, and we've been doing this, skills wise, probably about 30 years. So hopefully we know what we're doing, or 20 years, should I say? So hopefully we know what we're doing now. We partner with a lot of other companies with our training, like QA and Checkpoint. Hacker Point, as they call it, as their trading brand. So you probably come across our training, whether it be at Black Hat or somewhere else, by a different brand. But it's if you're into this sort of thing, you've probably come across us before in one way or another. Well, I'm going to hand you over to our main man to tell you about DevSecOps. As you know, DevSecOps is code is pretty important phase when it comes to developing now, and this ever evolving world around the agile situation now, it's actually impossible to keep on top of doing a pen test once a year on an application, because it's changing daily. So that's why the whole DevSecOps thing is now crucial if you want to survive in this current world. All right, hand you over to the main man, Jovin, if you could please take us from here, and at the end we will also do a thing for you where we can give you a free training course, but we'll get onto that later. Jovin, up to you.
Thanks a lot, Alan. So my name is Jovin Lobo. I am a senior security consultant working with Not So Secure. I have over 8+ years of experience with InfoSec. And most of my experience is around pen testing, mostly around web applications, mobile applications, infrastructure, and source code reviews. So I have, other than working as a pen tester, I also deliver trainings across, and I have also spoken at multiple conferences. So notably, it's B-Sides Dublin, CoCon, Nalcon, and Donify. So before we start, let's just talk about what all are we going to cover today. So I'm just going to introduce you to what DevOps is. I'm pretty sure that everybody knows what DevOps is. After which we'll talk about DevSecOps and why we need DevSecOps in today's day and age, and how we get there, from a DevOps environment to a DevSecOps setup. How do we go there? And we're going to talk about how we'll integrate security in the DevOps pipeline. We are obviously going to cover a lot of tools. So we're going to talk to you about the various tools that we use, or the various tools that could be used in certain environments. We'll look at a couple of sample implementations, and towards the end we'll just talk about the cultural aspects of it, because it's not just tooling that is required to achieve DevSecOps. There's a cultural aspect to it that comes along. So before I even move to the tools part, there's a small disclaimer. So the tools that are mentioned are not an exhaustive list, and at the same time, these are not any sort of an endorsement towards any specific tool or a vendor. Most of the tools that we mention are open source ones because of the availability that because they're easily available, and anybody can use them. And that does not mean we recommend these in the test and in your production or test environments as well. So before you use any of these tools, make sure that you thoroughly test them and validate them in your test environments, and before pushing these ideas onto your production. So what is DevOps? So DevOps is basically a combination or comprises of these various four pillars that we talk about. We have continuous integration, continuous delivery, infrastructure as code, and continuous monitoring. So these are the four pillars that form or that mainly comprise or that form the so-called DevOps. So what is CI? So CI is continuous integration is basically where you allow, it's a process where you allow developers to automatically integrate their code changes and and then the various other changes into a single sort of a repository, uh, which is also called as the software code repository. uh, so here a lot of your various platforms, such as your Git platforms, such as GitHub, Bitbucket, GitLab, come into the picture. So DevOps encourages this practice for allowing your developers to frequently merge their code into or frequently merge their changes, because DevOps is all about moving quickly and integrating as quickly as possible. Then we move on to continuous delivery. So this is the process of delivering software in short cycles in a timely manner and a reliable manner as well. So AWS defines this. So I'm quoting AWS here, where they say that continuous delivery is a development practice where code changes are automatically built, tested, and prepared for a release to production. So that pretty much sums up what continuous delivery is. To achieve this, servers or automation platforms such as Jenkins is used. So Jenkins is an example of an open source automation server that enables you to build, test, and deploy software. So in our further examples, we'll be looking at the integrations of how we've built the entire DevSecOps pipeline, where Jenkins is right at the center, and we'll look at some of these ideas around how Jenkins can be used around. Then we have infrastructure as code. So Jenkins bundles the entire application and then creates a Docker image. So there is a single Docker image that is then stored to the registry, and this Docker image is then pulled out, and you create various environments using that Docker image. Now, often before DevOps, where we used to, or rather in the olden waterfall models, the production, your staging, and your testing environments used to be separate. They used to be different. So you usually had these issues where certain code changes that worked in your development environments would not necessarily work in your test or production environments because they were different. So DevOps kind of solves this problem by creating a uniform platform across various your staging, production, and UAT environments, because you are simply using the exact same Docker image to create these environments. Then finally, we move to continuous monitoring. So continuous monitoring is where you have these agents that keep monitoring the logs. So as an example, we'll talk about the FELK stack, or the Filebeats, Elasticsearch, Logstash, and Kibana stack. So Filebeats are nothing but these agents that are installed on your logging servers, or the WAF logs basically, and these look for event changes or any log changes that happen. So once these log changes happen, these log events are then passed to Elasticsearch. So Logstash is then used for indexing these results, and after that, Kibana is used as a dashboard to view the results in a to view these results in a more informative manner, so that in a more informative manner, others. So This is a diagram that represents what I just said. So you have the developers that push their code using GitHub. Jenkins picks the code changes or any changes that happen here based on the triggers that are set. And using these build triggers, it eventually builds these artifacts. And then it creates staging and production environments using the Docker images that are stored on the registry. And then in the production environment will also have a WAF that would be set, and you'll have the file beats that would be monitoring these logs. And using the ELK stack, we have the operations that can view what is happening. So what are the challenges for security in DevOps? So DevOps, it moves at a very high speed, where you have like a build from, it can range from anywhere, a build a month to a build per day, and anything in between, right? So it's not possible with the traditional setup where used to have the traditional setup of security used to be where you first had the functional testers test the application, and once it is completely tested by them and all the issues are fixed, then towards the end, just before the release, you used to have the security team that used to come in and conduct their security tests. And any of these security issues that were raised would then go back to the developers and get them fixed, and the security team would retest this. But this kind of a setup or this kind of a traditional way of approach for security doesn't work in today's DevOps environment. So DevOps comes with a whole new set of tool sets as well. So it's no more just the web server and the code that has been compiled and run on these servers anymore. So there are a lot new more challenges, and the entire tool set is different, right? We have Docker containers, we've got Jenkins, we've got so many different setups out there. So the attack surface is also increased. So we also have to look at the various configuration of all these different changes out there. So in order to even conduct proper security tests, a lot of knowledge is required regarding the different environments and development knowledge of the application is also a must. So there is a lot of focus on also cross-skilling these security testers and your developers out there, because so here is where the cultural aspect comes into the picture. So security as an afterthought, like I mentioned, the traditional setup where you had source code review, dependency checking, compliance review, automated security scans, penetration testing, and security incidents and response. So these are the various different subsections of security, you could say. And having all of this done towards the end doesn't really make any sense. So the best way to do this is by shifting left. So the shift left testing process, or the shift left practice, is a way where you try to complete these stages at a much earlier phase, right? So all these stages need to be then completed at a much earlier stage. So all these security changes uh, need to be in this sort of a form. So this is called shift left, where you've shifted all these different security parts to a much earlier stage. So here we have the automated source code review and the dependency checking that happens in the continuous delivery process. Then we have compliance review and penetration testing, which happens in the infrastructure as code phase. And towards the end, you have the security incidents and response section. So what is DevSecOps? So it's the idea to achieve this entire secure by default design. So security has to be a part of so it's basically integrating security into DevOps and in the pipelines in an automated fashion. So here, obviously, whoever is implementing DevSecOps needs to have not only the knowledge of security, but also the knowledge of development and operations. So it is these three things, development, operations, and security, that come together and then create this entire sort of a unison to achieve something called DevSecOps. So it's not just about tools and skills, but it's also about culture out here. So why DevSecOps? Because obviously this makes it a lot easier, and in that way you do not affect the flow of the releases, because and this is the most natural form of implementing security into these into the DevOps model out there. So DevSecOps also allows you to smoothly scale your infra and scale your different processes, because you're now implementing these security checks and the security stages at the various in the pipeline itself. It's no more an afterthought. It's no more something that you have to do towards the end. It's a part of the pipeline itself. So how do we implement DevSecOps? So how do we achieve DevSecOps? Uh, System. Yeah, I'm sorry. Yeah. So how do we achieve DevSecOps? So we will look at the various stages in the entire pipeline, and we'll talk about how we can secure these DevOps pipeline. So the very first stage is to have something called pre-commit hooks. So pre-commit hooks. So Talisman is an example of a pre-commit hook. So there are many cases where we've seen that developers end up committing sensitive information onto the code bases. So as an example, in recently there were some open source Ruby projects on GitHub, and the developers ended up sharing sensitive keys onto the GitHub project. So how do we avoid things, these kind of accidents? So there is something called a pre-commit hook. So pre-commit hooks are configured to check your code base to and see if they have any sensitive information, such as your AWS keys, tokens, passwords, or any such sensitive information. So they work on regex. So what the hook does is, so every time you do a git commit, the hook is invoked. So once the hook is invoked, it uses its regex rule set to scan the entire code and see if they have any sort of these uh, sensitive information out there. So if you look at your AWS keys or your tokens or any of these SSH keys, there's a certain pattern that you can identify these through. So Talisman comes with a pre-configured, or rather a preset of rule sets that helps you identify all these tokens and all these different keys and sensitive information. It also lets you configure your own set of rule sets to identify any custom sensitive information. Let's say that you are using a certain custom token that's built by your organization, and somehow Talisman is not able to catch it because it doesn't have that rule set to identify this token. So you could configure or rather add this rule set to identify that token in a very easy manner. Similarly, the other way around, if there are certain false positives, like it's catching or it's flagging certain information that it thinks is sensitive, but it's not really sensitive. So, for example, let's say there is some hard-coded URL, and the hard-coded URL is just mapping to a static page, and Talisman flags it saying that there is some sensitive content in the URL or one of the get parameters. So you can make sure you can configure it to disable flagging of such content as well. So you can tailor your rule sets here. Next, after we make sure that the developers are sort of uploading or rather committing code without any sort of sensitive information, what next? So one of the biggest challenges in a automation or in a DevOps environment is because everything is running in an automated fashion, you need to provide access keys accordingly. Okay, so for example, if I want Jenkins to set up certain infrastructure, I have to provide it with the configuration files. And if I'm providing it with the configuration files, I also have to provide it with the credentials. How else will it create? So this is a big headache. And one way to resolve this is by using some sort of a secrets management tool. So as an example, we can talk about Vault Secret Management Manager by HashiCorp. So what Vault allows you to do is, instead of creating or hard coding your credentials, like for example, let's say you have a Redis configuration file, and you have to add your credentials, your username and password onto it. So instead of hard coding it, Vault allows you to create a token. So inside Vault, you can add your credentials and Vault will generate a corresponding token for it. And all you have to do is add this token inside your configuration file and link the configuration file to your Vault server. So that way, in case somehow your configuration files get leaked or they go into the wrong hands, all they have is a token and not the actual credentials of your servers. Similarly, even in the developers could use the Vault libraries. For example, Java developers could use the Java Vault libraries, and instead of hard coding the credentials in the code, like for example your JDBC connections, your database connections, instead of hard coding these values, they can simply map these to the token that is being provided by Vault, and this token will map to the actual credentials. So even inside your code or your configuration files, you need not hard code your credentials anymore. And Vault is open source, and it's a really interesting tool that can help you achieve all this in a very effective way. Once we have our software code repository up to date with without any sensitive information, either through the sensitive keys or through any form of hard-coded credentials, we then move on to Jenkins. So Jenkins can then look for can do this can cover the stage called software composition analysis. So what software composition analysis is all about? It's about identifying if you're using any third parties which are vulnerable. So these days, nobody codes from scratch, right? You end up using some sort of frameworks, some sort of libraries. In fact, there are frameworks for almost everything, right? So if you're talking about web development, there are hundreds of frameworks out there. So and there are frameworks in almost all languages. So all these frameworks eventually use libraries which may or may not be vulnerable at that point in time. So with these hundreds of libraries out there, you have jQuery libraries, you have Bootstrap libraries, and so on and so forth. And how do you make sure that you are not accidentally using a sensitive library or a library which is vulnerable? So for that, you have something called the software composition analysis. So in this example, we'll look at a tool called Dependency Check. So this is by OWASP. So what Dependency Check does is, uh, after you've committed your code, uh, uh, Jenkins, before building it, will look at the source code and identify all the libraries that are being used. It will then compare all these library versions. So it identifies all the libraries and their corresponding versions. And then what it does is it compares these with something called as the National Vulnerability Database. So National Vulnerability Database, or the NVD, is a database of all the vulnerabilities along with their CVE list. So CVEs are basically identifiers for specific vulnerabilities in specific products or libraries. So dependency check is going to cross-check your set of libraries that you've used and make sure that these libraries, are they vulnerable to any of these existing vulnerabilities. If so, it will flag and your build will fail. And then you can go back to the developers and make sure that you fix those libraries by updating the libraries, or you make sure you do not use any vulnerable component of that particular library in your code. Then we move on to something called SAST, or static analysis security testing. So this is a phase after you identified your libraries. Next is you talk about your actual code that you've written. So for that, you have different source code and analyzing softwares. So one of the open source software analyzing tool is your software source code analyzing tool is called SemGrep. So SemGrep will actually go through the code and see if you've written any vulnerable code. So this is the phase where you identify various vulnerabilities such as the SQL injections, cross-site scripting attack, cross-site scripting vulnerabilities, or any vulnerabilities where there is no sort of sanitation for any of the inputs. So the way this works, or the way a generic source code analyzer works, is it identifies the inputs from where a user can provide inputs. Example would be an HTML form, or it could be get parameters, so on and so forth. And then it identifies sinks, or where these values end up. So if these values end up in between a hard-coded SQL query, there is a possibility that it might lead to a SQL injection attack, so on and so forth. If these values tend to get reflected back by the server, then there is a possibility of a cross-site scripting attack. So that is how these softwares work. So SemGrep is a very effective open source software to identify vulnerabilities. From a commercial perspective, then there are several others such as Checkmarx, Veracode, so on and so forth, which do the exact same thing. So your SemGrep will run after your dependency check is completed and the SCA stage is done. You have this SAST stage, and the results of both these are then being pushed to something called a vulnerability management tool. In this case, it's ArcherySec. I'll come to this in a moment. So once we have completed the SAST and your SCA stage, we then move on to the deployment. So then the web application, or the application, is then deployed in the staging environment. So once it is deployed into the staging environment, we do something called the DAST, or the dynamic analysis security testing out here. So here we run some web scanner, in this case an open source web scanner named Zap. So what Zap does is it runs a lot of these web security or vulnerability payloads onto the running website on the staging environment. So we do this to identify, or to weed out any vulnerabilities that we may have missed in any of our previous two stages. So there are certain runtime security issues that you can find out only during a stage like your ZAP stage, or the DAST stage rather, where you run these web scanners on your existing environment. So as an example, there are these vulnerabilities such as your CSRFs, or some of these issues like clickjacking and so on, which can be only identified on a running environment. So, or certain issues of missing security headers on your servers. So your servers may not necessarily have all the security headers in place. So something of those kind of And those kind of vulnerabilities are examples which can be identified in the dash stage. Once this is done, we move on to the vulnerability assessment stage. So in this stage, we use tools such as OpenVAS to scan the physical servers that have been used out here. So OpenVAS looks at all the libraries that are used by your servers or your infrastructure in general. So the staging has your app server and DB server, which might be using Tomcat or Apache, any of the Apache servers. And then you have DBs where it might use MySQL or Postgres. So what if there are certain services running on these servers which are not necessary, or for example, let's say that there are certain ports open, like let's say there is an FTP port open on one of the application servers which might have been accidentally left out. So those kind of vulnerabilities can be identified by OpenVAS by actually scanning through the actual network and identifying vulnerable services out here. Again, all these results will then be pushed to something called Archery Sec, which we'll discuss in some time. Then we have something called compliance as code. So in the production environments, we need to follow certain compliance requirements. For that, we can run our compliance checks in the pipeline itself. So how do we do that? We have something called Chef Inspect. So Chef Inspect is a framework. So Chef is basically a Ruby framework. And based on the Chef framework, we have something called Inspect. So Inspect lets you write your compliance rule sets, and then you can run all these rule sets across your or onto your production environments. For example, one of the compliance requirements may be that it should adhere to your benchmarks, your CIS benchmarks. So let's say you have your Tomcat application and your application that needs to adhere to the CIS benchmarks. So how do you do that? In a normal situation or in a manual scenario, you'll end up looking at the configuration and running those scripts across. So in this case, you could have your entire CIS benchmark configured, or rather configured using the inspect framework, and you could run this in the pipeline. And the corresponding results can again be collated back to your Archery Sec or a vulnerability management dashboard. Then we have something called container scanning. So container scanning is done on your images. So initially when I started my webinar, I mentioned that how Jenkins would use one Docker image and then create multiple environments. Now the problem here is that what if your base image or the image that you've used might have certain vulnerabilities. So your base images tend to have a lot of other software installed in it, and those softwares might be vulnerable. So you are unknowingly adding, or rather introducing security vulnerabilities into your environments. So how do you prevent that? So that can be prevented by regularly having these, by scanning your container images. Trivi is an example of a scanner which allows you to look for these vulnerabilities in your base images, so that it makes sure that you do not have any vulnerable base image while creating or while sort of deploying your various infrastructure. And then finally, we have vulnerability management. So if you've seen all these slides, you can see that, how all the output goes to a common platform. So let's assume that you do not have a common platform. It would be extremely difficult to keep track of these vulnerabilities which are thrown by different scanners and different tools out here. So having, managing all these vulnerabilities would become a really daunting task. So how do you make sure that, how do you make it more efficient? Is by simply adding a vulnerability management tool out here, which has all these results collated into one place, so that it's easier for your security and development teams to keep track. So in our example, we've shown Archery Sec. So Archery Sec is an open source tool which is developed by one of our ex-colleagues here at Not So Secure. It's an open source tool, and Archery Sec allows you to integrate several tools out there. So you could use Archery Sec in your DevSecOps pipelines for security management. Then finally, once we have all the vulnerability management set up, our work doesn't end here. We also have to look at your live production environments for various incidents and that might happen in the real time. And for that, we have the FELK, or the Filebeats, Elasticsearch, Logstash, and Kibana stack. So here in production, we will be having some sort of WAF. So in this example, we'll talk about mod security. So mod security is a web application firewall that can be configured to identify live attacks that might happen onto your environment. So it's not just enough that we have a WAF out here. We also need to make sure that there are certain alerts that are configured. So for example, if there is a live attack that's happening on your infrastructure at any given point, uh, having WAF will definitely help. But what if there's no point when the WAF alerts are not reaching you. How would you know that it's happening real time? So you configure something called the FELK stack out here. So you have Filebeats, that is an agent that sits onto your production environment, and it listens to these logs. And the moment it identifies certain security attacks, it then creates these elast alerts, which is actually configured using Elasticsearch. And then you can have these alerts onto the dashboard using Kibana. So that way your operations team will have a live update or a live feed of any attacks that happen onto infrastructure. So this is how you have the entire security baked into your DevOps environment. So this is how you go from DevOps to DevSecOps. And these are the various stages that we just saw. So this is an example of a Java environment. As I mentioned, we'll be also looking at examples of different implementations. So from here on, we'll just cover a few examples as well. So in our lab, so the lab that we use to, in our trainings, we have created it using a Java environment. So in our labs, we use these pre-commit hooks. We use the Talisman pre-commit hooks. Then for dependency check or the SCA phase, we use dependency check. Then in the SAST phase, we use find sec bugs or semgrep. And for various other stages such as DAST, we use ZAP. For container security, we use Shrivi. For vulnerability assessment, we use OpenVAS. For compliance checks, we use Inspect. And all these results are then collated back to Archery Sec, where we have a complete view of how we can manage our various security aspects and have a look at all these various results. And also we have Vault Secret Manager to manage your secrets. So with that said, I'll give you a small preview of our lab. And there's a small video for you all to, have a look at. We have web-based IDs in place. And this is Jenkins of that. This is how we bake security in Devops and Devsecops. This is the example of talisman that I was talking about. So we have sensitive keys to be committed, and the moment you commit, the talisman flag out there. Talking about SCA again, sensitive keys that I use basically highlighted. Once you fix these issues, only then your build will run successfully. Using any vulnerable third parties out. We cover all these in our lab exercise, and this gives you a complete hands-on of not only understanding what securities, but by actually, doing it yourself, you have a complete idea of how to actually do it in the real world. We have to identify in this aspect. And the beauty of our labs is that we are achieving all this using open source tools. So all these tools are openly and readily available to anybody. And though we are using open source, does not mean that it is restricted to these tools. The knowledge that we gain out here can be translated to any environment. What you learn here can be applied to your commercial tools and commercial tools. These are the live attacks. These are the elastic alerts that have been configured. And then towards the end, we'll have a dashboard, as you can see here. This is actually set the management dashboard out here. So this will have all your skill results.
We seem to have developed some audio qualities here. We're trying to pick them up as we go.
Hello, am I audible?
On and off. We were losing you quite a lot there, so I just hope it hadn't too much for people.
Okay. So where did you lose me? So what was it during the video? Yeah.
Yes, it was during the video, Joven, but you sound fine now. You sound great. So apologies to anyone who understand that. Hopefully now you'll be able to hear Joven clearly. So yeah, no worries now. If you just wanted to carry
no problem. I'll just go back to these various aspects where if you've missed anything. So yeah, in the video, as you've seen, these are web-based labs. So all our exercises are done using a web-based IDE. So you don't need anything installed on your systems. So once you do this, the entire lab is about how you can bake security into your DevOps, achieving DevSecOps in the process. So here, I was just talking about how a talisman would catch your sensitive information. And we are going to do all of this in the labs as a hands-on exercise. Similarly, you have dependency check, so on and so forth. This is a public video, so you can, even after the webinar, you can just have a look at this. So this gives you a complete glimpse of what exactly will be happening in the sessions. So that said, yeah, this was also about continuous monitoring, where these live attacks can be then later viewed or using we'll be creating these pie charts and your dashboard using Kibana, and to identify these live attacks. So right from no security in a DevOps to completely all stages of security, achieving DevSecOps. That's all about it. So with that said, we'll look at the various tools of the trade. So this is just a generic list of all the open source tools out there. We don't endorse any of these tools, but it's just a heads up that you could use these tools for various aspects of your DevOps pipeline or the DevSecOps pipeline. So for threat modeling, you have various tools such as your threat playbook, threat specs, Microsoft threat modeling tool. So threat modeling is an important aspect before you even delve into building your softwares or having your releases out there. Then, as I spoke about pre-commit hooks, your software composition analysis, SAST, IDs, and so on and so forth. So there are several of these out there. So, example, dependency check. There are examples where certain software composition analysis tools specific to JS. So, let's say you are using a Node.js environment or a completely JavaScript environment where you have, let's say, Angular or React.js as your front end and your back end is Node.js. So in those cases, you can use something very specific like retire.js to identify the vulnerable third parties in your code base. So similarly, even in SAST, you have something called Bandit, which is specific to Python. Then you have FindSec bugs, which is specific to Java, Brakeman, which is specific to your Ruby environments, RIPS, which is specific to PHP. And then you have other tools such as SonarQube, which support multiple languages. So similarly, you can explore these. Again, just a reminder, test these in your test environments before you implement them into your production. You could also use IDE plugins on your developers' IDEs for identifying vulnerabilities. So you have FindSec bugs IDE as IDE plugin as well, which allows developers to identify bugs as they code. Then you have secrets management. In our case, we were talking about the HashiCorp Vault. Similarly, you have Keywiz and Confidant out here. For vulnerability management, we spoke about Archery Sec or Archery vulnerability management tool. Similarly, we have Jackhammer, which is again an open source vulnerability management platform, open sourced by Ola Caps. And then you have Defect Dojo, which is again a vulnerability management tool, which is a OWASP project. So personally, I have used Archery Sec and Defect Dojo, and they have a lot of support for a lot of different tools. So you need vulnerability management systems that also have integrations to the tools that you use, right? Because if you cannot integrate it with your tools, then you can't really view the results. For Dast, you have Zap, Acne, W3AF, and so on and so forth. So these are the open source tools out here. So you must have heard a lot about these commercial tools as well, like your Burp Suite, Fortify, and so on and so forth. Again, security in infrastructure as code, you have OpenVAS, you have Claire, DocScan. Again, depending on the environment that you use and your own preferences. So these are the various other tools out here. Similarly, for compliance as code, you have Kitchen CI and you have Inspec. You have also an interesting resource called the DevSec hardening framework. So DevSec hardening framework actually has a lot of these Inspec scripts as well, and which you can utilize to then use Inspec to actually run those hardening scripts. And for WAF, you have mod security, NAXSI, so on and so forth. So again, there are a lot of commercial tools out here in this space, which I'm sure everybody must have heard of. So does programming language matter? The answer is yes, only for two stages. But one is where your static analysis phase, where you're looking at your source code, obviously, because there are several tools that are specific to languages. So if we go a couple of slides back, as I was mentioning, you have your static analysis, security testing, where you have tools which are specific to language. Like if you talk about the first three ones, this is specific to Bandit, is specific to Python, FindSec bugs is specific to Java, and Brakeman is specific to Ruby. Similarly, even the STA stage, in this page also language matters. So for example, retire.js will only work in a JavaScript environment or a JS environment. But dependency check supports multiple languages. So you need to look for various tools that suit your needs and that suit your environment. So these are some language specific tools outlaid here. As I mentioned, we have Python, we have Bandit, and GR Audit, SonarQube. So similarly, then you'll see a lot of other tools out here like SonarQube, which supports multiple languages out here. So depending on your environment, you can have a look at or use these tools accordingly. Now, we did talk about our lab where we are using a Java environment, but the exact same thing that we achieve in our lab can be achieved for other environments as well. For example, let's say you want to achieve what we did in our labs for your Ruby environments. So like we earlier mentioned, you just need to replace two different tools out here for SC and SAS stage here. So instead of using FindSec bugs and dependency checker, you'll use Brakeman and bundler audit. Similarly, for PHP, you can use Sensio Labs and PHP CS security audit out here. You can also use RIPS framework here. Any tool that basically does the job for you and your specific environment. Again, for Python, we have Bandit and Safety that can be replaced, and you can notice that everything else remains the same out here. So this is your Node.js scan and npm check. Here you can also include retire.js if you need to, because that too works in a completely Node.js environment or a JS environment. So finally, we move to the towards the end and we talk about the cultural aspect. So automation is not the only silver bullet out here, and that will not be sufficient to solve your problems. You need to also inculcate a security mindset, especially if you're talking to developers and testers who do not know much about security. It's because in a DevOps environment, security is everybody's problem and not just a security tester's problem anymore. And because you are cross-skilling yourself as well, the developers also need to have enough knowledge about security, and the security folks need to have enough knowledge about having your development as well. So this cannot be achieved overnight, and this needs to be cultivated in a certain way. So you need to build that culture, and eventually you will reach there. So the various ways to do that is by looking out for people who can act like security champions in the company. So security champion is a term used for somebody who or a team member who understands security and development both. So he acts as a bridge between the security teams and the security requirements as well as the developers. So it's generally these guys who try to explain the security issues to the developers and make the security team also familiar with the development environment, so on and so forth. So the idea is about collaborating and being more inclusive, and of course to avoid any sort of blames because these environments are nobody is working in silos anymore, so everybody comes together and works. So this is a very important statement. The security team should try to eliminate the need of a dedicated security team, right? So if there are multiple DevOps teams which have their own security champions and who can, and who have an entire DevSecops pipeline out implemented in an utopian world, obviously you will not need a dedicated security team to look or to address your security issues. But that's really far from it. So these are some interesting references for you all. And the key takeaway from our webinar today is that, again, security is everybody's responsibility. Security needs to be embraced in your processes. And DevSecOps is like, it says clearly out here, it's not a one size fits all. If you look at the last, few slides where I've shown you different environments and how you can have different tools across, so that actually kind of explains this statement right there. So yeah, from here I'll hand over to Alan, who will talk about the various trainings and the training details out here. Alan, over to you.
Yeah, thanks for that, Jovin. Yeah, again, apologies for the poor quality audio halfway through that, why the webinar, why the video was running, because I hope it hasn't affected things too much for you. Yeah, but looking at training dates we've got coming up, there's a whole series of them, but these are the ones specific for DevSecOps in October. Please consider using the discount code if you want to do the booking. Best way to do it is go via our website and have a look at, see what's there. But there's a whole series of training courses, not just DevSecOps, all well worth looking at. Training courses can be run either, US timescales, UK timescales, or they can also be on-prem or remote, or for corporations or for individuals. So there's quite variations on that. There will be a questionnaire at the end of this. If you can just click on, you'll be happy to chat to us. What it would do is allow us to have a little chat with you. And if we do have a chat with you, it'll enter you into a free draw to have a free place on any of these training courses. So probably well worth having, for the sake of just having a little chat. And plus, if you're actually interested in doing some of these training courses, it's a bit of a no-brainer because you'll get some really good discounts. I shouldn't worry about scribbling down that number because we will be providing the slides to you with all the information and these dates anyway. But yeah, so please check out our website. But what we want to do now is go back to QA really. So I imagine there's a few of you have had some questions throughout the webinar. So yeah, please fire away. And Lizzie, if you could read them out for us, and then we can see what we can.
Yeah. Great, thank you, Alan, and thank you, Jovin, as well for that really informative, really interesting presentation there. It was really in detail, so I hope you all enjoyed it as well. We have had a few questions come in, so we might as well get straight into them if that's okay. One of the first questions that we've had in is, after I take this course, DevSecOps, what would be the next course for me as an ethical hacker? Jovin, so what would be the next course in the series if you've taken this one?
I think you can have a look at AppSec for developers after you've taken this course, because you get to understand from here, you understand how you can move from DevOps to implementing the security the security tools and everything out there. And after that, you could have a look at AppSec for developers, understand how as a developer you can fix these issues at the root, and you can have a look at maybe advanced infrastructure hacking from here on as well.
Great, thank you for that, Jovin. Another question that we've had in also is, are there any IT requirements to access the labs for the DevSecOps course?
Not really. You just like I said, our labs are completely web-based. So all you need to have is a web browser, which obviously everybody has. So we prefer if you have a latest Chrome version, because sometimes in an older browser, the web IDs may not necessarily work. And the other requirement is that you have a GitHub account, because we run all our exercises using your own GitHub account. So yeah, pretty much that's it. It's pretty simple requirement.
Great, thank you for that, Jovin. Another question that we've had in, really good one here, excuse me, is how can we take care of container orchestration, for example, Kubernetes, security, And where can we plant mob SF into pipeline? Does that make sense? Okay, great.
Yeah. So mob SF, you're talking about, and I'll just go back to one of the, I'll just use this as a reference if that's all right. So for mob SF, you can use it in place of Zap, right? So you could scan your, so in your staging environments, you can have your mobile apps deployed, and somehow integrate that with your mob SF to run your mob SF scans against these mobile apps out there, and then you can have mob SF integrate its results back to archery set. So does that answer the question?
Yeah, that's great. No, that's perfect. Thank you so much for that. And just one last question here that we have that's come in from an attendee is, are there any labs with GitLab CI instead of Jenkins?
No, we are using Jenkins, but the knowledge or rather whatever we do here can be translated to other platforms as well. So after you do this course, you'll know enough to actually translate whatever we've learned here to other environments as well. So we do not really use Git CI, but maybe after the course you'll know enough to do the same on Git CI.
Great. Well, that is all the questions that we've had in today. So I think we'll just wrap up the webinar here. I just want to say thank you to everybody that's joined today. Thank you to Jovan as well.
Yeah,
and
thanks everyone
for presenting. We do have a survey at the end of the webinar. We'd really appreciate it if you could fill that out for us. And please give us an email if you do have any questions about our webinar prize draw. So thank you so much for the webinar today. And yeah, I hope you all have a lovely day wherever you are in the world. Thank you.
Okay, everyone.